Hi everyone, this is Group 7. We have 3 members, Xie Yi, Xue Liyang, and Chen Zihan. The molecule is firstly found in 1985 and made in 1990. As a new material, it's still been developing for more applications. However, the multiply of atoms involved double bonds make Fullerene an excellent acceptor. Now it has available in catalysis and solar power generation fields.
Due to the amazing structure of the fullerene, the properties are quite different, not only physically but also chemically. For physical properties, it has density of 1.65 gram per cubic centimeter, submarine at 700 Kelvin and soluble in aromatic solvents and carbon disulfides. For chemical properties, it could form varieties of ions, from carbon-60 positive 3 to negative 6. It can encapsulate small molecules like metal atoms. It has hydrogenation and halogenation, and also has cycloid addition of aromatic function groups. For the synthesis, there are 3 physical approaches to make fullerene, and no chemical way was found. The most effective way is heating the carbon black in the atmosphere of helium. However, an electron current under artificial control. The current transforms the solid carbon into a plasma, and then, with rapid reconstruction of molecular structure, carbon-60 forms.
Hello everyone, this is Xie Yi for the introduction of the applications of the carbon-16. First of all, we are going to talk about the catalyst usage of the carbon-16. The carbon-16 with its three capital pi bonds is good at the electron accepting, and this feature helps carbon-16 work as a stabilizer or catalyst. For example, it's the conversion of a syngas to ethylene glucose, which is important in the pollution control of the heavy industries. This reaction is usually over a Cooper catalyst and requires a pressure at about 20 atms and above, because it's somewhat difficult to make the Cooper atoms and the cuprous ions coexist. So yeah, it's somewhat difficult. It's somewhat expensive, but if we add some carbon-16, the complement with the carbon-16 and the Cooper atoms has an equivalent with both the cuprous ions and the carbon anions, which can significantly increase the numbers of the cuprous ion much, and the complement can change the electron distributions of the carbon atoms, which also promotes the generation of the hydrogen radicals. Both of the 2 points increase the reaction rate of the conversion. The next applications is in terms of the solar panel. As we know, the solar panel is just an diode that accepts photons. The positive and negative junctions of diodes is just made from a semiconductor crystal divided by a trace number of particles. For example, the sulfur atoms can be added into a silicon crystals. After adding, the molecular orbital of the crystals owns a little more electrons than it used to be. And if we put some fullerene into the silicon crystals, the number of electrons in the molecular orbital will decrease oppositely. If the positive and negative junction in contact with each other, an electric electron field will be generated. Such electric field will hinder the electron current in the opposite direction, and if electron gaining a photon from the solar, it will be accelerated in the electric field and generates a stable electron current. The fullerene, if we mix into a semiconductor crystal, it usually takes a large volume, which can interrupt the structure of the semiconductor crystal efficiently. So it can generate a great process in the great effect on the photoelectric process.
There are many challenges for the carbon-60 for the synthesis principles. Nowadays, with little information of intermediates in the composite process, also the features is not much, so the further research is needed.